Hello everyone! Today in this quick demo, I'm going to show you one way of implementing the pane architecture methodology that I talked about in my previous video. Briefly, let me explain again what this methodology is all about. So it's based on the spec-driven development where you have two phases basically. You have the AI native architecture phase and AI native development phase. First, the AI native architecture phase consists of the architect and AI agents who work together to build the architecture of the solution. For that, the architect needs to work with the business, figure out the requirements throughout many work sessions, and at the end, the architect needs to have the understanding of basically what needs to be built so that he can, with the help of AI, figure out the right architecture to begin with. And for that, once we're done, we have the architecture documentation and specs. We have the architecture scaffolding, which is done mostly by the AI based on the specs that we write and based on all the business discussions that we had. Then we have the tests, of course, and the architecture guardrails, which are all things like instructions, hooks, skills, any type of instruction markdown, that protects the architecture integrity. Once we have all that, we go to the next phase, which is the development phase, where you have the dev team that consists of the human developers and AI agents, which work together and they build the documentation and the specs from which the AI, and of course with the help of humans, builds the feature code and the feature tests. And keep in mind that all that lives and lies on top of the protected AI native architecture. So it lies on top of what we built already here. So that's why we need to have clear understanding of what the requirements are, what the business is asking, so that we can build good structure that can hold any feature and future development, and to be sure that we don't have any technical debt from vibe coding. We don't want vibe coding. Anyways, we have the specs. From there, we build the code and the tests. Once we're done, we have the pull request governance, which consists of AI agent checking the code, of course. And then if all is good, we have a developer checking the code as well. That's how we keep the human in the loop throughout the whole software development lifecycle. At the end, we have tests and code scans. And if all is good, we have a repository that's protected by guardrails, AI native by design, and governed by AI and humans. That's in a nutshell. And now let me show you how you can implement something like this in code. So here is our Visual Studio project. As you can see, we have Claude MD, which references the agents MD, which has the what, the why, and the hows of the project. For example, we have the tech stack, we have the base code structure. We have some rules like spec first, constitution file is always at the top. We have some commands that run the project. Then we have some documentation. We have ADRs. For example, here we have an ADR that says we are not using authentication because this is just a demo and authentication will make everything harder. We have the features documented here. And we have the context, which is the most important part. This is purely for the AI. We have core markdown files for the backend. So we have the rules that the backend agent that you see in a bit needs to follow. We have the code structure. We have the same thing for the front end, the code structure and what they need to do. Keep these files short. Okay. We have the dependencies and the constitution, which is the most important file that needs to be followed at all times. And you can see here that we have links to all the docs. We have spec first always, we have vertical slices, we have tests are mandatory, dependency discipline, so we can use only approved dependencies that are inside dependencies MD. New ones require explicit user approval. So that's guardrails right there. And some other stuff. We have the definition of done. So each feature needs to have a spec. We need to follow the architecture, use only approved dependencies. If backend work, then read the backend MD. Front-end work, read the front-end MD. For writing tests, read the test MD, and you get the idea. We have the specs MD, which explains how the specs needs to be written. We have system architecture. We have the tests MD, which explains how the tests have to be written. With some examples, we have the design system here with the primary colors and secondary colors and fonts and all sorts of typography. That's how we make sure that the AI writes features, UI features that are consistent in terms of colors and fonts. We have the specs. So here's the template that each spec needs to be based on. And here's an example of such spec, add to cart. It's approved currently, and some details, some requirements, and as you can see, all of them are currently checked because they were implemented. Some design information, dependencies, and that's the specs. Also, we have inside Claude 2 agents or 2 agent employees. One is the backend agent, one is the front-end agent, and they know how to write code based on our markdown instructions here. We also have hooks. Currently, we only have one hook, which protects the constitution file, because I don't want AI to edit the constitution file. I only want humans to edit the constitution file because it's extremely important file, and these instructions there live at the top. So if you change something there, it can backfire. So you really need to be sure that what you're changing is good, and that's why you shouldn't let AI do it for you. We have workflows here, and the important one here is the Claude review, which reviews our PR code, our PRs. Here are the instructions. So for example, read the constitution, which is supreme authority, and follow that. Figure out the specs, and if there are no specs for that feature, keep it as blocked, and some other rules. And let me show you this right now. I created a new feature, held endpoint, without any spec files, without following the rules that we created in the beginning. And when it comes to AI checking the code, and as you can see here, it's blocked because of spec first violation. There is no spec in the context spec that covers the held endpoint, which is exactly what we want. And this is this step right here. So we have the code, it's pushed, but then the AI agent checks it and sees that it's not compliant to what we specified in the beginning when we were building the architecture in the first phase here. So this one is really important. We need to create this first phase in such a way that it's followed by the AI agents, it's followed by people, it's easy to understand and easy to extend. So it outlives us. Otherwise, if you're vibe coding, then you end up piling a lot of technical debt. And at the end of the day, there comes a day when you simply cannot extend this system anymore, and the system dies basically. So let's see, do we have anything else? I've shown you this. And I think that's it actually, guys. That's what I wanted to show you. I really hope it was useful. And like I said, this is more of an art rather than science. You can structure your solution in a completely different way. You might have some other agents, you might add skills, you might add some other hooks. The main idea is that you always start with specification, you always document whatever you're building. Don't vibe code, because that's a terrible idea, and that's my message here. Start with the specification. Start with understanding what the business wants, document that, write it down, have some specs, have some guardrails, have some good architecture with tests around it. And then you start implementing feature by feature. Make sure that each feature is specified, because that's, after all, documentation for you. Tomorrow, a month after, you can always go back and see what's been done and how it works. With vibe coding, you don't have any history. You just vibe prompted something, you think it's done, but tomorrow you realize that you're having troubles. You have tons of technical debt, you don't have any documentation, and that's the beginning of the end. Thanks so much for watching and have a great day.